Yes, sir.
So shall I start the class now?
Okay, sir.
ఎవరో unmute లో ఉన్నారు. So can you see this PPT?
Yes, sir.
Okay. So in the last class we have discussed about the critical voltage build-up in a self-excited generators. Okay, and the critical speed and the critical field resistance. Okay, what is the critical field resistance? The critical field resistance is the resistance below is a line which is drawn and it is a tangent to the magnetization characteristics. The critical field resistance is the tangent which is drawn to the magnetization characteristics, and the slope of this characteristics will give you the critical field resistance. Okay, so if you see that any two points on this, so let us assume these are the 2 points because this is a straight line. Okay, so I will take this color here. So this is the critical field resistance line. This blue line is a this one is the critical field resistance line. So just assume that these are the 2 points A and B. Okay, onto the lines. So the value OA will correspond to the field current of particular values. P, let us assume. Okay, so this field current will give you the voltage of OA, and the corresponding to OB, the voltage OB, this will be now Q. Okay, so this PQ is the field current. PQ is nothing but your field current, IF, and AB is the voltage. So you can find out your critical field resistance, RCR, RFCR. So this will be equal to the voltage. This is equal to the voltage AB divided by the current, that is the field current PQ. So you can measure this length, so you can find the value of this critical field resistance. Is it clear, everyone?
Yes, sir.
So
Sir.
next one. Next, I will take the another value here. Uh, from this point to, or I can take the another characteristics here. So just you see, this is the same waveform what we are discussing. Okay, so this OA, the line OA is the RF line or RSH line. Okay, and then this OB line is the critical field resistance line, and this is a resistance line which is more than your critical field resistance. Then there is no buildup of the voltage. So the voltage buildup takes place up to the resistance, which is nothing but your critical field resistance. Below that only there is a buildup of the voltage takes place in the self-excited generators. If the resistance above this critical field resistance, there is no buildup of the voltage. So in this case, for this line, no voltage buildup takes place. No voltage buildup takes place. Okay, so we have to consider these points for the RF line and also the critical field resistance for the open circuit characteristics. Then I'll take the 3 points here. This is the point S, which is taken on the open circuit characteristics, and this is the point T. This is the point T on the RF line, and this is the point Y on the field current. Okay. Then, so we have the voltage Ys. So we can have the total voltage of Ys. Okay. So So just I will take the voltage, voltage Ys. So this is the 2 points. This point, from this point to this point. This is the voltage Ys divided by the voltage Ys divided by voltage Vt, voltage Yt, voltage Yt, this point. So this voltage must be equal to the speed. This voltage is proportional to the speed. So this voltage Ys is producing the speed of n1. So this speed we have to consider as a speed n1 divided by this line. So just you are considering that our field resistance line is tangent to the open circuit characteristics for a speed of n2. So this second curve is the open circuit characteristics for speed n2, and this first one is the open circuit characteristics for speed n1. So as the speed n2 is less than n1, so your open circuit characteristics is reduced, and it is making that our field resistance line is tangent to your open circuit characteristics for n2, and therefore this speed is known as the critical speed. This speed is known as the critical speed. So here the critical speed is known as the speed at which the open circuit characteristics is drawn, and the RF line, the field resistance line, is tangent to this open circuit characteristics. Then that particular speed is known as critical speed. And therefore here I can consider this as a speed, but it is a critical speed. This is a critical speed n2, and therefore with this we can find out the critical speed ncr. This will be equal to the voltage Vt. This will be the voltage y into t divided by the voltage ys into the speed n1. So this is the formula to be used for calculating the critical speed of a particular generator. Is it clear?
Yes, sir.
So how can I find the critical field resistance now? RCR. This is the critical field resistance. RCR will be equal to. So for our open circuit characteristics, so this is our open circuit characteristics. Just we are taking these 2 points. Okay. And here I will consider this point onto your RCR line, and this is a point S like that. Okay, so I will consider this is a point capital A, and this is the point B, and this corresponding point is P I will consider. Okay, and here this is a point for Q. Okay, so RCR will be equal to the voltage. We have to find the slope of your RCR line. That's it. So the voltage AB divided by the current PQ. This will give you the critical field resistance from your magnetization characteristics. So these are the two important parameters we should consider for calculating the critical field resistance and the critical speed. Okay. So is it clear now? Shall I proceed further? Are you
Yes,
writing
sir.
anything? Yes. Are you writing?
Yes, sir.
Okay. So I will define the critical field resistance here. The critical speed, MCR. Okay, the critical speed is the speed is the speed at which the speed at which the DC shunt generator, the DC shunt generator just fails just fails to build up build up with no external resistance, with no external resistance in the field circuit, in the field circuit. So our generator has to be rotated with the speed at which your open circuit characteristics is uh, having a tangent of our RF line, only RF line. So there is no external field resistance. If you add up external resistance, now the slope of the curve will be increases, then it reaches a critical field resistance. If you go on increasing the resistance, what happens? The resistance may be increased and the slope of the line may be gets raised. So there is no buildup of the voltage. Okay, so this is about the voltage buildup in the shunt generators, and also we have seen the critical field resistance and the critical speed. Okay, now I'm going through the next topic, the failure to build up of the voltage. So anyone, can you tell me what are the reasons for not building up the voltage? So we have gone through all these methods. Okay, so anyone, can you tell me what are the reasons for not building up of the voltage? Generators లో voltage buildup ఎందుకు కాదు? Any reasons? Anyone? Srinivas? Yes.
So,
So first of all, voltage buildup ఎందుకు? ఫస్ట్ బిల్డప్ కావాలంటే మనకు కావాల్సిన ఫస్ట్ రీజన్ ఏంటి? ఫస్ట్ మెయిన్ పాయింట్ ఏంటి? వోల్టేజ్ బిల్డప్ కావాలంటే సెల్ఫ్ ఎగ్జైటెడ్ జనరేటర్స్ లో
current.
no. Just you have seen here this one, this point. So first of all, when there is a residual flux present in the field poles, then it will produce some residual voltage. Residual voltage will be built up, and because of this residual voltage, then a small amount of current will be flowing through the field winding, and this field winding will build up a voltage up to this point. Then this voltage again builds up the currents in the field winding, and because of this current, again the voltage increased, and then this will be forming like this. Okay, so this is the voltage. Then because of this voltage and some field current will be raised, and this rise in field current again rises the voltage, and this rise in voltage again builds up the current, and this current again builds up the voltage. So in this process, now the voltage buildup takes place. Okay, so this is the process of building up the voltage. So here this will be added to your field currents, and the field current is raised, voltage buildup raised. Field current is raised, and then the voltage buildup raised. So this is a process of increasing the voltage in the self-excited generators. So first thing is what which is required is the mainly one point. One is the residual flux. So first thing is we required residual magnetism should be present in the field poles. Okay, and then second one is, so because of this residual flux, the current will be developed, and here this current should, the second thing is the field current if should aiding, it should be added to the residual magnetism. So this direction of your field current must be in the same direction of your residual magnetism, then only voltage buildup takes place. Okay, then third one, your RF line, RF should be less than RCR, and the fourth one is your critical speed resistance speed should be greater than your rated speed. Sorry, your speed of a machine and your speed of a machine must be greater than your critical speed resistance. Then only voltage buildup takes place. So these are the four reasons to failure. Okay, so these are the same four reasons for the building up, not building up of the voltage. Okay, so if the self-excited generator fails to build up the voltage at no load, it may be due to any one of the following reasons. One is no residual flux. Okay, so if there is no residual flux in the residual magnetism present in the field poles, then there is no voltage buildup takes place. Okay, because of this residual magnetism only, some small amount of field current is passing through the field winding, and this field winding is generating the field current, and because of this field current or this field flux is added to the residual flux. Therefore, there is a cumulative process, voltage buildup takes place, and that small amount of the voltage will again generate the field current, and this field current is added to again the previous field current. So this is a cumulative process. Then there is a buildup of the voltage takes place. Now, if there is no residual magnetism is present in the machine, what we should do? Okay, so for that, the remedy is that we should remove the field winding of a self-excited generator, that may be shunt, series, or compound. Then we should remove that, and then we need to run the machine as a separately excited DC machine. Then once it is separately excited, it gets some field current, and with the help of this field current, uh, flux will be developed, and your machine will be building up the voltage. So the remedy is that we should run, if there is no residual magnetism, we should run the machine as a separately excited generator, and then small amount of the field current will be allowed to flow through the field winding. Then we can take it out again, and it will be connected to your shunt generator or for the series generator. Is it clear? Is it
Yes,
clear,
sir.
everyone? Yes. Then the second one is, what? The field connections are reversed. So field connections are reversed means, instead of adding the field flux which is produced by the field winding, it should be added to the residual flux. Okay. So if you see that there is no buildup of a voltage in the generator, it may be due to field connections are reversed. So just we have to interchange that. So if you see that this is the field winding which is connected in this fashion across your armature terminals. Okay, so this is your armature terminals, and this will be connected like this, and you are measuring the voltage, let us assume. Okay, then this voltmeter is not showing any reading, so this voltmeter is showing zero reading. So this may be due to, the first one is, this may be due to residual magnetism. No residual magnetism. If there is no residual magnetism, then what we have to do, just we have to remove this field winding, and we need to use the external DC circuit, and this should be connected. Okay, so this will be removed like this, and then your field winding will be connected to the external circuit. Then this voltage, this field winding produces or gets some field current, and this is called as a field flashing. This is called as a field flashing. Then it gets some residual flux. Then you can observe that there is a voltage buildup takes place in armature circuit. And then the second one is due to the field connections reverse. That means here this is not there. Now your field winding is like this. This is your shunt generator I'm assuming. Then you assume that this is a Z and ZZ. Okay. Now this is having small voltage. So because of your IF will be 0, then it has shown your reading of 10 volts. Let us assume. For a field current of IF is equal to 0, then this voltage is showing 10 volts. Okay, in previous case, first case, it was 0. It will show IF is 0 and your voltage will be 0. So it shows that there is no residual magnetism present in the circuit. Then what we are doing, just we are removing the field winding and we are separately exciting. So this is the first case what we have to observe. And in the second case, then you see that IF is 0 and your voltage is shown here, 10 volts is shown. So it indicates that your first thing is present. So this machine is having a residual magnetism, and then first case is confirmed. So it is no problem with the residual magnetism. And then now you increase the field current. Okay. So because of this 10 volts and field current has to be increased. But what is going on? Because of the reversal in current, reversal in the field winding, your voltage goes on decreasing because your current flux is in the opposite direction. Okay, so if the flux is not adding to your residual flux, you can observe that voltage gets reduced. So what we have to see, this is just we have to interchange this direction. So this should be taken as ZZ and this should be taken as Z1. So this means there is a field reversal is taking place, then the direction of current will be reversed. The direction of current is reversed, and then the flux which is produced by the field winding is added to your residual magnetism. Then there is a voltage buildup takes place. Is it clear? So what
Yes,
is the
sir.
remedy for this? What is the remedy for the second option? Just we have to interchange. Just we have to interchange the field connection. Then the direction of flux will be reversed and it will build up the voltage. Okay. Then third one. What is the third one? So just you observe that the field current is there and your voltage is also taking place, but it is not build upping of any voltage. Only it is taking only 10 volts. There is no build up. So this may be due to your speed is less than the critical speed. So your speed n is less than your critical speed. But for the buildup of voltage, what is required is your speed must be the speed must be greater than NCR, and therefore you have to increase the speed. The speed can be increased. The speed of the generator can be increased with the help of generator. With the speed of the generator can be increased. Generator can be increased with the help of prime mover. With the help of prime mover. Okay. So you can increase the mechanical energy to the prime mover so that the motor can run at higher speeds as your prime mover is connected to your generator. Now this can be increased. The speed of your generator can be increased. Then your voltage buildup takes place. Okay. And next one is high field circuit resistance. High field circuit, because you are keeping here. I'll take another color here. So here, just assume that you are keeping a rheostat in this position. Okay, and this is varied to vary the field current. So what is the RSH now? RSH is equal to your normal RF line plus RST total. This is the field rheostat resistance of the rheostat, and therefore your field winding resistance is added and it is greater than your critical field resistance. Then also there is no buildup of the voltage. So when you are wearing the rheostat, this should be kept minimum. This should be kept minimum. Okay, so the resistance should be very less in the field winding. Then this resistance may not be more than your critical field resistance. Then there is a buildup. Okay, so if you see that there is no buildup, it may be because of this resistance. So just you reduce the critical field resistance of the line below the critical field resistance. Then you may see that there is a buildup of the voltage. So these are the main four reasons for not building up of the voltage in the shunt generators. Is it clear?
Yes, sir.
Yes? Anyone, if you have any doubts, you can ask me. So I will proceed further.
Okay, sir.
Okay, then now we'll solve a problem. So the problem on this magnetization characteristics. Okay, just note down the problem. First, note down the problem. Okay, అయిపోయిందా?
Yeah, okay, sir. Complete, sir.
Okay. Okay. So shall we solve graph sheet పెట్టుకోండి అందరూ. So for drawing finding the critical field resistance and speed, we need to draw the graph. I'll have to keep a graph with you. ఉన్నాయా అందరి దగ్గర
Yes, sir.
గ్రాఫ్ షీట్స్ ఉన్నాయా? So just చూడండి, just I'm taking the graph sheet here and I'm drawing the details. Okay. So here I'm taking the 0, okay. So here I'm taking this characteristics 0, okay. So this x-axis I'm considering this as a field current IF, okay, and this is IF in amps, okay, and then y-axis I'm considering it as a y-axis I'm considering the voltage, okay, EMF generated voltage EA in volts, EA in volts. So I will take the scale of 30 volts. 1 unit is equal to 30 volts. This is going to be 60, 90, 120, 150, 180, 240, 270, and 300. Okay, because your voltage is up to 270. And on x-axis, I'm taking the current of 0.5. Okay, and 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. Okay, so these are the scale. This is scale what I'm doing. Okay, so just you mention here the scale. Always you have to mention the scale. Okay, x-axis, x-axis. What is x-axis? 1 unit is equal to 0.5 amperes. Okay, and y-axis,
30 volts.
1 unit is equal to 30 volts. So this is the scale what I'm taking. Then next you have to take the values 0.25. So at the middle of this one 0.25 we need to take 6. Okay, so 36. So each one, so 1, 2, 3, 4, 5. So each unit, the small value will be 6. Okay, the small values will be 6 individual values. So this is a 36, and I'm taking it middle of the one. So this is a 0.1, 0.2, 0.3, 0.4, 0.5. So at the middle of this line, I'm taking this point. This is my first point. Okay, corresponding to 0.25. Okay, corresponding to this point, this is a 0.25. This is a point. So next point where I put, this is 0.5. The second one is a 0.5. The voltage is 72. Okay, so 72 means this is 66, 72. So at this point, so 0.5, 66, 72. This is by point. Can you see this clearly? కనిపిస్తుంది అందరికి?
కనిపిస్తుంది క్లియర్గా.
Yes, sir.
Graph clear కనిపిస్తుంది అందరికి? Okay, so I'm putting this point here. The next one 1. Okay, so the next field current is 1 and our voltage is 138. Okay, so 138 means this is a 120, 126, 132, 138. So at the third point I'm putting this point. So at the third 1, this is yours 138. Okay, and next 1.5. So 1.5 దగ్గర ఎంత 188. So this is a 180, 186. So small deviation here. This is a 188. This one is 188. And next one 2. 2 దగ్గర ఎంత 225. So 225 means 180. 24. Sorry, this one is wrong. So this is, so 180. This is 210, 240, 270, and 300. So it should be 225. So 210, 210, 216, 24, 25 here. This is 225. Okay, next 2.5 దగ్గర 250. So 6, 12, 12 plus 3, 6 here. 2.5 దగ్గర 46, 52, 55. So this is 255. Sorry, this should be 250 కదా. So 246. That's it. So this is not the point. 246 plus 4 across. This is the point. And next 3 దగ్గర 270. Exactly, this is 270. So these are the points. Okay. So now we join. So normal గా మనకి మీరు వేరే ప్రాబ్లం చేసినప్పుడు గుర్తుపెట్టుకోండి, ఇక్కడ IF 0 దగ్గర మీకు కొంచెం వోల్టేజ్ ఇస్తారు. దట్ మే బి 10 volts or 15 volts లైక్ దట్ అలా ఇస్తారు. But in that problem, he has not mentioned any residual flux. So that's why I'm directly taking it from the 0. But you may see that there will be some residual flux at field current 0 also. So ఒకవేళ మీకు ఇక్కడ 10 or 15 ఇచ్చారు అనుకోండి, you have to take this point here at this point, and then you have to start joining this point. Just remember. Okay. So here he has not given anything. That's why I'm directly joining these points from the origin. So this is my magnetization characteristics. Okay. So this is your OCC curve. This is the OCC curve at 1000 RPM. Has given 1000 RPM. Okay. డ్రా చేశారు అందరూ?
Yes, sir.
ఓకే, డ్రా చేసిన తర్వాత ఏం చేయండి అంటే జస్ట్ స్కేల్ యూజ్ చేసి, ఓకే, స్కేల్ యూజ్ చేసి మీరు ఏం చేయాలంటే దీనిపైనకి టాంజెంట్ లైన్ డ్రా చేయాలి. Okay, I'm drawing this with a different color here. We need to draw a tangent line like this. Okay, so normal గా మీకు ఇక్కడ నుంచి టాంజెంట్ లైన్ దీనిపై నుంచి వస్తుంది. ఇక్కడికి వచ్చేసి స్కేల్ తో డ్రా చేయండి, ఇలా వచ్చేస్తుంది టాంజెంట్. దిస్ ఈజ్ యువర్ టాంజెంట్. So we need to draw this tangent line. నాకు ఇక్కడ స్కేల్ లేదు కాబట్టి జస్ట్ అలా వస్తుంది, బట్ యూ నీడ్ టు డ్రా యూజింగ్ ది స్కేల్. ఓకే, స్కేల్తో ఇది డ్రా చేయాలి. మీకు ఎగ్జామ్లో కూడా ఇలాగే వస్తుంది, జస్ట్ యూ రిమెంబర్. ఓకే, జస్ట్ డ్రా ద టాంజెంట్ లైన్. సో దిస్ ఈస్ మీటింగ్ ఎట్ పాయింట్ పి హియర్. ఇది టాంజెంట్ డ్రా చేసిన తర్వాత we need to draw the RF line. Okay, so RF line draw చేయాలి అంటే మనకు ప్రాబ్లం ఇచ్చాడు చూడండి. The first thing we have to consider here is the first problem. So first what we have to see that we have to find the value of the field resistance. Here we need to find only the field resistance, not the critical field resistance. It is directly the field resistance of the field circuit for a voltage of 240 volts. So for this we need to take the voltage. Okay, so on no load, first question on no load, with EA is equal to 240 volts, 240 volts. Draw a horizontal line from this 240, and this 240 line point is drawn here, and this is a meeting at point A. This is the meeting point at A. Okay, రాయండి. Draw a horizontal line. Draw horizontal line. Draw horizontal line to intersect open circuit characteristics at point A. At point A. At point A. Then the corresponding field current. The corresponding field current on x-axis is the corresponding field current on x-axis is this one, this point here. Okay, so if we have to see that this is your corresponding field current, this should be drawn onto x-axis. So this is nothing but your 2.25. Okay, is 2.25 amperes. That is IF is equal to 2.25 amperes. Okay, and therefore the slope. So now we need to draw the line. Okay, then we need to draw the line crossing this point. So this is your RF line. This is your RF line. Okay, this is a crossing your same point. Okay, so the slope of this RF line is, now the slope of line OA is your critical field resistance RF. Okay, slope of OA is RF, which is equal to 240 divided by 2.25. So this value is given as 240 by 2.25. This value is 106.67 ohms. So this is your first problem, field resistance. This is the first one, field resistance. Is it clear? అర్థమైందండి ఇక్కడ?
Yes, sir.
అర్థమైందా? Just what I'm doing here, just taking the no load voltage of 240 volts and then corresponding field current I am measuring. That field current is 2.25. So to find the slope here, so RF is equal to 240 divided by 2.25. This will give you your field resistance. The next one, what we have to do is, we need to find out the critical speed. The second one is we need to find out what is the second point. The critical speed we have to find out. So to find the critical speed, just I will take any point onto this. I'll consider one field current. Okay, just I will consider 1.5. The field current 1.5 I will consider. Just make the points onto this. Here, this is touching here, and this is touching here. Okay, so this is the point Y I will consider, and this is the point T, and this is the point S. Okay, this is the point S. So as per our critical field resistance formula, NCR is equal to the voltage YT, the voltage YT divided by voltage YS, voltage YS into your speed N1, that is a normal speed N1. Okay, so this is the speed N1. Now we can measure this voltage YT. This voltage YT will be equal to, this is a 150, 156, 162 and 168. So this is equal to 168 divided by this one is 210 plus 6, 216. Let us assume this is a 216 into our speed is 1000 RPM. Now can you calculate this? Just you calculate and tell me. Just అది కనుక్కొని చెప్పండి నాకు just one.
777.
హలో
So
హలో ఎంత వచ్చిందమ్మా క్యాల్కులేట్ చేశారా?
777.77.
సో 777. సో ఇట్
77.
విల్ వేరీస్. సో నార్మల్గా నేను ఇక్కడ కరెక్ట్గా డ్రా చేయలేదు. సో మీరు నార్మల్గా ఇది డ్రా చేయండి. ఈ వాల్యూస్ మే బి రాంగ్. ఓకేనా, నేను తీసుకున్న వాల్యూస్ మే బి రాంగ్ బికాస్ దిస్ ఈస్ నాట్ ది ఎగ్జాక్ట్లీ టాంజెంట్. ఓకే, సో బట్ అస్యూమ్ దట్ దిస్ ఇస్ 770. చెప్పండి ఎంత వచ్చింది?
777.77.
0.77. Okay, this is RPM. This is your critical speed. Now your speed is more than, you are running your machine at 1000 RPM. So this is greater than your critical speed, so that there is a buildup of the voltage. Okay, సో ఇది మీరు ఎప్పుడైనా జనరేటర్ని ఈ స్పీడ్ కన్నా ఎక్కువ స్పీడ్తో రన్ చేస్తే మాత్రమే మనకి వోల్టేజ్ బిల్డప్ అనేది వస్తుంది. ఓకే, సో మీరు చూడండి, మీరు అబ్జర్వ్ చేయండి. దిస్ మే బి 660. మీకు ఇలా వచ్చినా కరెక్టే, 600 to 700. సో యాక్చువల్ ఆన్సర్ ఇస్ 660 RPM. మీరు నార్మల్గా పర్ఫెక్ట్ గ్రాఫ్ డ్రా చేసి ఏ పాయింట్స్ లొకేట్ చేసినా కూడా మీకు వచ్చే ఆన్సర్ ఇది. ఓకేనా, మళ్ళీ నేను 777 చెప్పినాను అనుకోకండి. బట్ దిస్ ఇస్ ద ప్రొసీజర్ ఐఎమ్ టెలింగ్, బికాస్ ఐ కెనాట్ డ్రా ది ఎగ్జాక్ట్ straight line curve for the open circuit characteristics. Just I have drawn it by the line, so we are getting the 777. మీరు గ్రాఫ్ డ్రా చేసి చూడండి, ఇట్ మే బి అరౌండ్ 660 to 700. ఓకే, అది వచ్చినా మీకు కరెక్టే. అర్థమైందా?
Yes, sir.
Yes. Okay, so now how to find the ఇదే ప్రాబ్లం కి చూద్దాం. How to find critical field resistance? So RCR, I need to find the critical field resistance. So this to find out this, just I will take this point here, okay, and this point. Okay, so this is a point A, let us assume. This is a point A. I assume 180 volts. This is a point A, and this will be the point B. Okay, and corresponding field current ఎంత వస్తుంది ఇక్కడ? This point here. This is a P, and corresponding to this one, this voltage here, straight line పైనకి తీసుకుంటే, this is going to be like this here. Okay, so 1.5, 1.65 అనుకుందాం ఇది. So this is a 1.65, and the current వచ్చేసి 1.1, 1.2, 1.3. Okay, P point. P is 1.3 and Q is 1.65. So RCR is equal to, you have to measure this voltage. So AB. So RCR will be equal to AB divided by PQ. So AB is how much voltage? This is a 240 minus 180 divided by the field current is 1.65 minus 1.3. So this is 240 means it is 60 divided by 0.35. Okay, so 60 divided by 0.35, how much is the value? This is 60 divided by 0.35. So your value is going to be 171.43 ohms. So this is your critical field resistance. Okay, so your resistance, now you measure how much you are getting the RF value. This value is going to be 106.67. So you are having your field resistance, and then your critical speed, your speed of a machine n is greater than your critical speed, then you are having a buildup of the voltage. Okay, so is first thing is satisfied now, your RF is less than RCR, and the second thing is your N is greater than NCR. So these two conditions are satisfied for the buildup of the voltage. Okay, so these are the conclusions from this problem, and this is the way of finding the critical field resistance and critical speed. Okay, any doubts in finding this problem?
No, sir.
Any doubts? Anyone?
I think
Okay,
I think no doubt, sir.
okay, then so now I'm closing here. Just you see here, just I will show you one thing. This is our syllabus. As per your JNQ curriculum, you are having the syllabus now. Can you see this syllabus?
Yes, sir.
కనిపిస్తుంది అందరికి?
కనిపిస్తుంది, sir.
So in the first unit, we are about to finish the only compound generators and series generators. Anything is missing here? So principle of operation is finished, the action of commutator, constructional details, lap and wave windings, multiplex windings, laminated armature, EMF equation, armature reaction we finished. Okay, and the commutation we finished, methods of improving the commutation, and excitation, separately excited and shunt excited generators. Now we have gone through the buildup of the voltage, then critical field resistance and critical speed we finished, and the causes of failure of self-excited generators and their remedial measures we finished, and also the last one, the load characteristics of shunt generators we finished. Am I right?
Yes, sir.
Then the pending one is the characteristics of series and compound generators is pending here. Okay, so tomorrow I will take up one more problem. Shall we solve one more problem on this critical field resistance?
Okay, sir.
Yes, sir.
Okay, so tomorrow we'll take up one more problem and we finish these characteristics. Okay, then as per your JNQ syllabus, for the first mid exam we need to finish up 2.5 units, but we are very lack in syllabus coverage. So I thought every faculty is about to finish 2.5 units. Am I right?
No, sir.
Yeah. మనకి ఏ యూనిట్లో ఉన్నారు మిగతా ఫ్యాకల్టీ అంతా?
Lata ma'am is in still first unit, sir.
ఓకే,
Mechanics, sir, second unit.
స్టార్ట్ చేశారా?
Middle ఉంది, sir.
ఓకే,
EMF ఫస్ట్ చాప్టర్ అయిపోయింది, సార్.
అయిపోయిందా?
ఎస్ సార్.
మ్మ్.
ఏఈ కూడా అంతే సార్, ఫస్ట్ చాప్టర్ అయిపోతుంది.
ఓకే, మరి వాళ్ళందరూ నాకు ఎగ్జామ్ 2.5 minutes కావాలని అడుగుతున్నారు. సో
సార్
విల్
ఇప్పుడు
డూ
ఈ
వన్ థింగ్.
ఎగ్జామ్స్ కూడా ఉంటున్నాయి కదా సార్.
అదే కదా, నాకు సడన్ నేను ఫాస్ట్గా వెళ్తున్నాను నేను అనుకుంటున్నా, బట్ చాలా స్లోగానే ఉన్నాను నేను. మీకు
యా,
అర్థమవుతుందా ఈ పాయింట్స్ అంతా? బాగుందా? అసలు ఎలా ఉంది?
అర్థమవుతుంది సార్.
జస్ట్ ఎనీవన్, మీరు స్పీకర్ ఆన్ చేయండి, మైక్ మీ వీడియో కూడా ఆన్ చేయండి. నాకు ఒకసారి జస్ట్ ఫీడ్బ్యాక్ కావాలి, ఒక 5 minutes. ఫాస్ట్గా. ఈజ్ ఇట్ క్లియర్? నేను ఒకవేళ వీలుంటే సాటర్డే మన ఫ్రైడే రోజు క్లాస్ ఉంటుందో ఉండదో, ఫ్రైడే రోజు కూడా తీసుకుంటాను నేను, వేరే క్లాసెస్ తీసుకోకపోతే.
ఓకే సార్.
ఓకే, సో సాటర్డే వీలుంటే, ఒకవేళ ఫ్రైడే కుదరలేదు అనుకోండి, సాటర్డే మాత్రం నేను 2 hours తీసుకుంటాను. ఓకేనా?
సాటర్డేనా సార్?
సాటర్డే 2 hours తీసుకుంటాను మార్నింగ్ సెషన్లో. మళ్ళీ వేరే ఎవరికి ఇవ్వకండి. ఓకే,
ఓకే సార్.
సో మనం మెషిన్ మోటార్ స్టార్ట్ చేస్తాను. సో నెక్స్ట్ వీక్ కల్లా మాక్సిమం అట్లీస్ట్ 2 units ఫినిష్. ఓకే, నేను ప్రాబ్లం ఉంటే నాకు ముందే చెప్పండి.
ఓకే సార్, నేను చెప్తాను.
ఓకేనా? షల్ వి క్లోజ్ నౌ?
ఓకే సార్.